Okay, welcome everyone to the last session for the day, and also for the whole DrupalSouth 2025 event. So this one will be deep telemetry with eBPF and Rust by Nick. Please, join me welcoming Nick to this session, to the stage. Thank you.
Hey everybody, how's it going? Welcome to the final boss here at the final talk of the day before the closing remarks. So who am I? I'm operational lead at Previous Next. I'm architect of the Skipper platform, and today we're going to be covering quite a bit of content. So we'll be talking about the state of monitoring, our journey through open telemetry, and ultimately how we ended up building an APM solution on quite a bit of cutting edge technology. Quickly, the state of monitoring. So does anybody know what this is? It's the Triforce. I like to think of the state of monitoring as the Triforce. You've got metrics, logs, and traces. And together, we get this full picture. We have, let's say you're debugging a request, and you get that with these three combined, you understand the characteristics of CPU memory, an event that occurred, say I logged into the site or submitted a form, but then I also get this lower level, how much code was executed, where did I spend all my time? With those three things combined, you have a very rich understanding of what's going on. And I don't know where the top of that went. Oh, there we go. And if we look at metrics and logs, there's a plethora of technologies out there for handling metrics and logs, whether they be paid services or well-established open source alternatives. And it's doing the same thing again. I don't know what that's about. Anyway, so traces. But when it comes to traces, that's a bit trickier. So these are kind of the industry standard for obtaining traces in production. And for us, it's primarily New Relic and a bit of Blackfire. This web transaction time is burnt into my retinas. We've been using it for a very, very, very long time, and we've got customers using it. It's from New Relic. It's on the front page. It's where you go to understand you've got your AppDex score and then kind of an average of where you're spending all your time. And then you can go into transactions and understand in your code where you're spending your time as well for a request. But when it comes to local, those tools don't align very well either. So we use things like Xdebug, SPX, Blackfire, XHProf. We use a lot of open tools for our locals. But ultimately, what we found was we have to pay to deeply understand our applications in production. Something like New Relic actually costs quite a bit. In the past, the free tier would get you by. Now you enable the free tier and you get kind of pinged about a week or two into the month worth of free quota for a small site, and it's game over. You don't get any more telemetry for the rest of the month. So like the price of admittance is actually quite high. And we felt this across all our clients. To round out the local development tooling, we really, really, really like SPX. I highly recommend that people dive in and look at SPX. It's a PECL extension that you can install. It comes with a web UI. It's awesome, but a lot of our cons were around it doesn't integrate with anything out of its ecosystem. It's quite a complex, beefy extension. It recommends only run this on non-production, so it's not really for production. It's all in our local stack. So we're still stuck. What's production doing? What is production doing? We have average P95 and P99 for our requests. This is how we understand what our applications are doing. This is one of our golden metrics. And yeah, when you get a P99, so the top 1% of slowest requests, and you get this big old spike to 30 seconds, you kind of go, well, what were we doing in there? What was happening? And it takes a lot to be able to understand what's going on. I wrote a blog post about it too. This was a bit of a side quest, but yeah, a bit of a journey around how we got to P95 and P99. So recommend everybody go check that out. Now, we wanted to roll something out. We want to understand what's going on. So our instinct was to look at Open Telemetry. So for those who don't know, Open Telemetry is a high-quality, ubiquitous, and portable telemetry solution to enable effective observability. It's a very lofty goal. It's this big, overarching project that is trying to solve this problem for every language in the form of a spec and an ecosystem, and then under that are all these special interest groups, and PHP being one of them as well. Like I said, very lofty goals. It wants to handle traces, metrics, and logs. And it wants to be a drop-in solution. So you can just drop it in place of your PHP app, just like any of those managed providers, and it'll start picking up data for you. And then ultimately, it wants to be open and vendor neutral. So you would install one of these solutions and then get to pick where you want to send all that data to. So you can still install Open Telemetry, pick up your PHP traces, and send them off to New Relic. This ecosystem is huge. It's second to Kubernetes. I mean, this is if you look at the scale at the bottom, they're not very close, but just in terms of size, they're getting there. To me, this shows a very good sign of maturity, because we're not just talking now about running our apps on infrastructure. We're talking about actually diving deep into understanding what our applications are doing. And from here, I want to talk about traces with Open Telemetry. So integrating Open Telemetry, our story. So there was 3 ways that I saw that we could integrate Open Telemetry. The first one being, the first thing we have to look at is the Open Telemetry PHP library. So this library allows us to add code to our project. So here's an example of a PHP app. There's the roll dice endpoint, and then I start a span. So this is the beginning of a point of interest, and then I can add an event and then close it off and kind of turn that into an atomic unit of X got done. So dice got rolled, and then that can go through the telemetry system and inform you X took X period of time. This span took X period of time. In fact, we use this library right now in core, and it's a part of the automatic testing framework. So it's not running on your sites right now. You don't look under your seats and you've got Open Telemetry running, but it is run as a part of the automated test suite for regressions. The next place to look was Drupal Contrib. So in terms of Contrib, there's a very small ecosystem of folks implementing Open Telemetry. Core looked a little too hard and quite a big push to get some kind of patch into there. So for Contrib, this is where a lot of the innovation currently is. I highly recommend people to go check out this module, but it's still, to me, it's still very early. I see where it's heading, but at the same time, it was still left a lot to be desired in terms of, okay, where do we want to put all those spans? Like it was pretty open. So I kind of went to the third option. I went, okay, so let's look at this auto instrumentation piece. So this is a PECL extension that can be installed, and it allows you to put those hooks wherever you want. So you don't need to go edit Drupal's code base. You can define your own bit of PHP and then say, okay, at the beginning of, for the demo, in this example, for the demo class, so that could be the Drupal kernel handle function, or the Drupal kernel and then handle. I could then inject a span before and one after, and then I'll get a span, and I never had to modify core at all. So looks pretty cool. We actually implemented this, and just did a little proof of concept. And started to get some spans back, so we were getting a bit of traction. So you can see here we're going to the front page and we're starting to see things like page cache was getting triggered. We were starting to instrument our application. And then we took a big swing and went, well, what if we add PDO? What if we start adding spans? So there's a whole set of libraries that you can add in and then just start to get these spans for free. So PDO being one. So you can start to understand all the MySQL calls that are being triggered. But then that begs the question, what's the cost? What's the cost of it? So we decided to start measuring it. We're like, okay, auto instrumentation, thumbs up. We use K6 for our load testing. So let's set up a load testing framework in our CI so then we can check the before and the after. I highly recommend everybody go check out K6 if you want to do any load testing. It's a very, very cool tool. Our pipeline consisted of this. Umami is awesome for trying to spin up a demo site and get started. It's also great if you want to test these kinds of things, right? Because you've got a preloaded site ready to go with some content. So our automated CI would install Umami, get a baseline, so run the test suite, get that number, enable open telemetry, get that number, and report back. So for us, at the time, it was actually quite a massive hit. So as you can see, a baseline was 75 ms, and that took it right up to 1.6, if you keep rounding, 1.7 seconds. So that was a bit alarming at the time. There is a happy ending to this whole thing. We'll talk about it at the end. But at the time, that was quite alarming. And as you can see, all three options have kind of been exhausted because it left me with the question, okay, well, if we're going down any of these routes, what classes and functions do we want to orchestrate? What performance are we willing to trade off? Because that's a massive hit. And then ultimately, okay, any of these solutions, how do we actually roll this out to all these sites? Like, we want everybody to have it, and the price of admittance being pulling in developers to pull in dependencies, manage dependencies, is just quite high. So we were at a fork in the road. And it was time to, we decided to build our own. We built our own. And it was called Compass. So it's a tool. It's got the lovely tagline, it's a tool for pointing developers in the right direction for performance issues. And if anybody wants a shiny holographic sticker of that logo, come talk to me after. But for now, who wants a little demo? Yeah. I knew it. So I brought a demo. If I can find my terminal. Okay, no ace up my sleeve. I'll up the stack. Don't worry, you don't have to read that, but the stack's up. Actually, let me just... And I probably spelled it wrong. I'll just down to be 100% sure. Make up. Okay. So I actually have an Umami site running. Just believe me. Actually, we could probably go to that too. So Compass is running here right now, and I have a local terminal user interface, so a TUI, just to visualize this data. If I go back up here, and I go to my Umami site, that took a second, right? So let's investigate, shall we? So I have a whole bunch of traces here now for that request. So you can see, well, that looks about right. You know, I've got sites default files, CSS, styles, you know, Drupal uses PHP to modify our images, generate CSS, JavaScript, sure. But let's go down to the GET request. So as you can see here, I'm actually picking everything up. Every function call, whether it's in PHP, so it's like a class of, like it's a function, or inside of PHP itself. So we can see the path. It was a GET request. We can see how long it was. And if we start scrolling down, it's quite interesting because Drupal kernel handle is generally the majority of a request. It's in index.php. It's the entry point, but why is it only like a fraction of the request? So just to demonstrate, let's go looking. You can see Drupal does a lot. You get a lot of visibility. And we'll just scroll down. We're doing lots of stuff. But ultimately, I saw this morning. I was like, this is a great use case. See, we execute a lot of things. But, right a sec. There we go. Yes. Look what we're doing. Cron on terminate. So we're returning the page, like handles being executed and returning the page. But ultimately, we're then spending quite a lot of time doing stuff in shutdown. So we get a lot of visibility with this type of tool. And then not only can you see the spans, so all TUI'd up, but you can also go and look at the totals. So I could have just quickly, easily swapped to this trace's totals and gone, well, yeah, the second one from the top is 85% of our time was spent executing cron. So you get this really sort of quick understanding of what's going on, and it's quite deep. Oh, that is the demo. Yeah, I'll take claps. Because then I gotta flick back to this. Okay. So who wants to know how that was built? If I can conquer the slides. All right, so we'll go back to the Triforce, right? So the goals of this kind of project are it's open source, it's simple, and it's stable. So it's open source, it's simple in how it's implemented in a way. Like it's not one of those massive extensions that say New Relic or Datadog or one of them. Like you look at, it's open, but you look at the code base and go, oh my God, I cannot follow this. I tried. But then also this push on stability. And I'm still getting the titles. So here's what we built. So we built a PHP extension, and then there's an eBPF program, and then a collector on the other end. And we'll go through all this, so it's okay. We can do it. So step one, I just want to talk about probes. So there's this concept of USDTs. So they've been around for a really long time. They're a part of actually Unix and Sun Microsystems. It's this idea of putting a probe point in your application. And the way that I like to think of it is it's kind of like logs without storage. So anywhere in your code base where you would go, I want to log X, so I indexed 3 items, you could put a probe. And yeah, I like to think of them as like logs without storage, because you're not actively logging it out at any time. You're putting this probe in place so then other tools can then hook on there and then start to pick up that data instead. So you're not incurring this massive cost of ingesting all these logs, maybe to never be queried. But then you can turn on tracing tools to debug issues and then get all that data out. So we've got these sort of probe points. And then if we look at PHP, this is the life cycle of a request. So we go through an initialization phase, we then execute the PHP code itself, and then the request shuts down. And I wanted probes for each one of these. So then we can define when the request started, all the work that was done in the middle, and then when it shut down. And so how do we do this? PHP 8.0 has this thing called the Observer API. It's, as you can see, it's a blog from Datadog. They and many others had this same problem of trying to, in PHP, it was very, very, very difficult to kind of jump in and orchestrate and understand and put these sort of points before and after a function call, so then they could introspect and understand, okay, this is what's being called and this is how long it took. It was very, very tricky before 8. So everybody got together and came together, and this is what happened, Observer API. Now, if we drill in a little bit, when a function's called, Observer API kicks in. And you have this opportunity to go, okay, in the first lane, X function got called, and then we registered a before and after function. And then the function went through and executed all that. And then you can see in the second lane, it was the first call for the bar function, and the observer went, no, I don't want to add anything there. And then all subsequent calls, you don't need to make that decision and inject anything more. And that's sort of where a lot of the speed for this comes from. A tricky piece of this is how to set context between all this. So just very quickly, it's through a memory address. Don't worry about it. But ultimately, the next step was to put all this into a PECL extension. We got an observer API. We know we want to do probes. Okay, cool. Now, how do we actually do this in practice? So there's this amazing Rust framework called PHPER, and it allows you to write PHP extensions. And then you inherit a whole community of build tools where previously you were kind of stuck writing C code. So in this case, this example, I've written a little bit of Rust and I've declared a say hello function. So it kind of blows open the doors for all kinds of extensions to be written that would traditionally be slow if they were written in PHP, or just bringing in other Rust libraries from the ecosystem. And then you can expose them to PHP through PHPER. But we're using this to do our observer API and our probes. So the next piece is Rust has, where we would say modules, Rust has crates, and there's this probe crate, and it allows you to, like I said, put these probe points into our code. So we have this probe lazy, and then we declare the probe. So this is the PHP function call. So this is when every PHP function gets called, it passes through this probe in the extension, and then we get the request ID. We also get the name and all the details around the name of the function. And then we also get the time that was elapsed, so how long the function took. So you can sort of see how we're starting to get this big fire hose of data. And what that ended up looking like was 3 probes added by a PECL extension using Observer API, and these are them. So request init, the PHP function call, and the shutdown. That's just proof that we did. Now what? We have probes. Hooray! The next thing is that we want to actually attach those probes and pull data in. So this is where eBPF comes in. So eBPF, with the cute little logo, is kind of brought down to, or summarized as JavaScript for the Linux kernel. So there's this whole ecosystem that's booming in the container native world. And if you want to kind of know a little bit more, I've got a link later, but the idea is that over time, this kind of small team of people that wanted to do networking, software-defined networking at the Linux kernel layer, and wanted a lot of kind of flexibility, slowly added patches and got them committed to the Linux kernel only to finally rip off the mask and go, hurrah, we have a whole runtime in the Linux kernel now that lets us do network security and observability. And once it's committed, that's it. But it's also safe. So the other way that this could have been done is a kernel module, but that always ends up pretty bad. So that was the CrowdStrike situation where you're operating at such a low level that now if something goes wrong, you're toast. The whole machine's toast. But with eBPF, that's not the case. This is that talk. Now, to write eBPF, this is a snippet. So I don't expect you to all go home and start writing eBPF out of the gate. But really, it's where the line 1 and 2 is about us declaring what probe to attach to. And then lines 9 to 13 is us wiring up all the information from the probe into an event. And then line 15 is us submitting the event up to a different application. So in 18 lines of code, we've written an eBPF program that now we're pulling all this low-level tracing data from. So step 3. So So now we've covered the extension, this low-level bit of kernel programming, and now we're going to the collector. So I hope you had your bingo cards for technology, but we got this little cute guy. So we got Go. So we're very proficient in Go. It's pretty much all the skipper infrastructure is written on. So this is kind of a bit more familiar territory for us now. We've gone through writing extensions in Rust, eBPF programs, and now we're finally coming out at the other end. This company called Celium are these massive advocates for eBPF, for the eBPF ecosystem. In fact, they are a company that has written one of these software-defined networks, and now they're writing security tools and all kinds of things on top of this. And they have a great library for getting started. This is kind of a simple example of how, so we're going back into eBPF land. I'm actually writing a program that's going to read every single time I type something into my command line terminal and hit enter. So when bash and it reads a line, I can then write my Go side of it to consume those events and then print it out. So, and then ultimately you get something like this. So Echo, thank you for coming to my talk. We're not at the end, but then in another terminal, execute my program, and I'm listening for these events and I'm printing out what was actually executed. So you can kind of see the utility in this for security tools, right? Now I can understand all the commands that are getting executed across my infrastructure. So, but for the collector, we use that same approach to consume all that tracing data and kind of bundle it up into what you see here. So from visualize, so from the demo. So that's the journey that we did to get here, to get into our TUI console, to understand what was being executed. Now, how does Compass perform? Because we did some performance testing right before. We should be doing it again. So yeah, let's compare it against New Relic. So same pipeline, except I added another build to the parallel task, which was New Relic, and we came out the winner with us considerably faster in this case. So hooray for us. To me, this is a good sign of moving forward and knowing that we're on the right track. So where to from here? Well, I want to go back to OpenTelemetry. So I've been a part of the OpenTelemetry community for a couple of weeks now. So I've started joining the special interest group meetings and talking about Compass and trying to contribute to the community as a whole. And through that, I showed them the previous PR, and then we were able to actually, turns out it was a setup error. So it's a common setup issue for OpenTelemetry setups, and it was a config, changed it, and now it was back down to 13 MS is the difference as well. Now, if I saw this at the time, would I have gone on that massive journey I just went on? I don't know. I honestly don't know. And I'm kind of glad that I got that original result, because we have we have a lot more data available to us, and we don't have to go and orchestrate all these libraries across all our applications. Now, does that mean it's all over for that solution? I don't think so. This is me with my crystal ball and where I'm kind of pushing towards and heading, but I think that side of things, so the core contrib auto instrumentation space for Drupal, traces should actually be a lot more high level and a lot more focused around the render of the page to me. So being able to look at a page load and then look at the traces and go, well, these are all the components across the page, and this is how long each one of them took to render or to build as a part of the page. And ultimately, what we end up with is for us, and this is our stack, but what we end up with is this very rich, deep stack of information, all tied together by a request ID. So we get our CloudFront logs for Edge, like for information about the request. Nginx logs. FPM gives us CPU and memory. Application Hotel gives us what I said before, that sort of page breakdown. And then Compass comes in with all the lower level function calls, everything that was actually executed as a part of that work. And then finally, the managed services in the background, like database and Redis. So if anybody wants to give that demo I did, you can go to this repository, run makeup, and then there's a example as the steps that you can take to have a quick play as well, like in this repository. And thank you.